Bernoulli's theorem. Bernoulli's theorem states that for an ideal liquid, which is an ideal liquid, which is not compressible, number one, which is non-viscous, number three, streamline, which is ideal liquid is what? Incompressible, non-viscous, streamline, right? For an ideal liquid, pressure energy per unit mass, kinetic energy per unit mass, potential energy per unit mass is always constant. To understand this, consider a pipe of non-uniform area of cross section. Here pressure is what? P1 at the position A of the pipe from the ground level. What is height? H1. What is area of cross section? A1. What is speed here? V1. Now at the position B, what is height? H2. What is pressure? P2. What is area of cross section? A2. What is speed? V2. The density at the position A is ρ1 and density at the position B is ρ2. Now tell me, liquid is flowing from A to B. Liquid is flowing from A to B. It means pressure at A is greater than pressure at B. It means P1 is greater than P2. It means that the pressure will do work in pumping the liquid from A to B. What is that work done? P1 A1 V1 minus P2 A2 V2. P1 A1 V1 is what? Pressure energy per unit time, right? In 1 second P1 A1 V1 is the work done there, minus P2 A2 V2 is the work done here. The difference of the two work done will do what? It will increase the kinetic energy. It will bring the change in kinetic energy, plus it will bring change in potential energy. Because liquid is flowing from here to here, there is change in kinetic energy. Liquid is gaining height from H1 to H2, so it is gaining in potential energy. Therefore, according to work energy theorem, the total work done is equal to change in kinetic energy plus change in potential energy. Now students, P1 A1 V1 minus P2 A2 V2 half m V2 square minus half m V1 square mg H2 minus mg H1. What is A1 V1 A2 V2? M upon rho, equation of continuity we have done in the last lecture. So A1 V1 is what? M upon rho. A2 V2 is what? M upon rho. This m gets cancelled. P1 upon rho minus P2 upon rho half V2 square minus half V1 square GH2 minus GH1. What is P1? We will transfer terms containing 1 on one side. P1 upon rho half V1 square GH1. P2 upon rho half V2 square GH2. So 1 terms on one side, 2 terms on other side. Pressure energy per unit mass, kinetic energy per unit mass, potential energy per unit mass initial at the position A equal to kinetic energy per unit mass half V2 square, pressure energy per unit mass P2 upon rho, GH2 potential energy per unit mass at the position B, they are equal. Therefore P1 P upon rho half V square GH a constant. This is what Bernoulli's theorem. It is very important, students. If the tube is horizontal, in that situation, just look here in this section. If the tube is horizontal, then what happens? Now concentrate everybody. If the tube is horizontal, then H1 is equal to H2. Therefore, pressure P1 upon rho plus V1 square upon 2 equal to P2 upon rho plus V2 square upon 2, or you can say P upon rho plus V square upon 2 a constant. What is this? A constant. Are you getting what I am saying? Multiplying throughout by 2 rho to P plus rho V square equal to a constant. Okay or not? Okay or not? हमने क्या किया? We multiplied throughout by rho. So what you get? P half rho V square constant, because density is constant. Constant into constant, another constant. So students, what do you find from here? You find that pressure is equal to constant minus half rho V square. Pressure is what? Constant minus half rho V square. This is very, very important. You might have noticed the roofs of the huts during the storms blows. How come? The wind is traveling with a great velocity. So pressure at the outside and pressure as the inside is different. Outside pressure is less because it is constant minus half rho V square. Inside pressure is more, therefore there will be a lift. It will be lifting up. Same way you have got a Bernoulli lift in aircrafts. When aircraft is running on the runway, on the wings of the aircraft, air eddies are formed, and the speed of the eddies on the upper portion of the wing is very, very high. The pressure is more, down one, lesser is 60% lift in the aircraft is due to Bernoulli lift. So there are number of applications you can do. Do you know, students, whenever there is an aircraft, like a fighter aircraft is, in the sky making exercises, you find a white line formed behind the aircraft. Some people say it's smoke. No, it's not smoke. When aircraft is flying with a 3 Mach, 4 Mach, Mach is the speed, right? It's very, very high. Then the wind traveling with the aircraft is also very high. As a result, what happens? Behind the aircraft, suppose this is the aircraft, behind the aircraft there is a less pressure. All the water vapors in the atmosphere gets condensed, so artificial clouds are formed. So that white line behind the aircraft is due to Bernoulli's theorem, that is pressure is equal to constant minus half rho V square. When the aircraft is flying very high, तो इसके पीछे what happens? The pressure is decreased, the water vapors get condensed. That is a artificial clouds formation. So hope it is clear. Thank you.